So the next thing is that we need to figure out there's going to be a comparison of hydrolysis of chlorine substituted compounds. Uh, when you talk about hydrolysis is simply a reaction with water, or it's kind of a decomposition with water. Okay, so it's a reaction or decomposition with water. Okay, so the basic summary. So you're going to get exactly the same question. Okay, it's going to come exactly in the same way. So the first thing is that uh, this chlorobenzene, it has no hydrolysis, no hydrolysis whatsoever. Then you have your halogenoalkanes. They have hydrolysis. For that, you need certain conditions. You need NaOH aqueous and reflux, heat with reflux. Okay, that's the condition. And if and this is your old AS reactions. This is, I mean, the middle one, the halogenoalkane, that's your old SN1, SN2 reactions. So we're going to study those again. And then you have acyl chlorides, the one with serial bond O and Cl. So these ones they have very strong hydrolysis. Okay, even with cold water. So you have very strong hydrolysis with cold water, and the observations over here would be that you'll see white fumes of HCl are going to be formed. I mean, this is the overall summary of the reactions. Okay, so first thing, just remember, uh, no hydrolysis. You do have hydrolysis, but you would have to heat the reaction mixture. And over here, you have very strong hydrolysis, a very vigorous reaction. So strength of hydrolysis, that is increasing. Okay, so you started off with no hydrolysis, and then you all of a sudden have very strong hydrolysis on this side. So starting with the first one, why does chlorobenzene not hydrolyze? Okay, that's the first part. So no hydro. We need to explain that. Okay, why is there no hydrolysis of chlorobenzene? बल्कि I'm just going to बल्कि यही लिख लेते हैं. No hydrolysis of chlorobenzene when chlorine gets directly attached to benzene. So what's wrong with this one? Okay, so I'm going to draw benzene and I'm going to draw the ring. Okay, that's what my benzene looks like. And there's a Cl that's attached to it. Let me put it in this. So there's a Cl that's going to be attached to it. Now, what happens in this case is that why does it not react with water? So what's going on is that Cl has a lot of lone pairs, and benzene has a whole pi electron cloud. So all of these they overlap, and when they overlap, you end up with a lot of electrons. You end up with a lot of electrons. I mean, there's a lot of overlapping happening, and you end up with a lot of electrons over here in this area over here. So that's the first thing. So which is why nucleophiles are not going to be, they're not going to be attracted to it. The OH minus one, ठीक है, remember water has OH minus one. So that OH minus one is not is definitely not going to be attracted to a lot of electrons. It's actually going to be repelled. So there is no attraction. Even water is going to be water, which is kind of a weaker nucleophile because the water lone pairs also have a negative charge. So they're not going to be attracted to a place where there's a lot of electrons. Okay, so nucleophiles, are repelled. ठीक है? Is this part clear? That why chlorobenzenes are not reacting with water.
Yes, sir.
ठीक है? So the way you're going to write this is that, or you're going to explain this is that the lone pairs on Cl, they overlap with the benzene pi electron cloud. And what that does is that puts a lot of electrons in this CCl bond. So when the bond has a lot of electrons, that means the bond strength increases. The CCl bond strength and charge density increase. So it's going to be harder to break the CCl bond because of the extra electrons over there. So charge density increases, which then repels nucleophiles. The nucleophile example is water and or OH ions. ठीक है, all of them are attracted to positive charge. They're not really attracted to electrons. ठीक है, that's the first thing. Is that all clear? Maheen clear? Amna, everyone else,
Yes,
Zuhair.
sir.
That's the first thing. And remember, this is how you're going to explain this. The next part is halogen That's your AS. ठीक है, so we're just going to recap what we're going to recap this in a kind of a bit more detail uh, about halogenoalkanes. So halogenoalkanes undergo mild hydrolysis, which means that you would have to heat them. So kind of mild hydrolysis, slow reaction. Of halogenoalkanes. So what's the first thing? I'm just going to jump to SN1, SN2 reactions. Uh, so if you have a primary halogenoalkane, do you remember what type of reaction was it? SN2 or SN1?
Sir, SN1?
Okay, so primary halogenoalkanes, they underwent not SN1, they underwent SN2. ठीक है, but remember कि primary would undergo SN2, and I'm going to explain what SN2 is. The SN2 reaction was that if you have a primary halogenoalkane, so it's going to have one carbon chain. So, for example, if it has one CH3 methyl group, and it's going to have two H's. So what happens is that the carbon has got a positive charge, and the Cl has a slight negative charge because the CCl bond is going to be very polar. So if you have a nucleophile like OH minus one, then that nucleophile is going to get attracted to this. It's going to get attracted to this positive carbon. Okay, so that is attracted to the positive carbon, and the electrons in this bond are going to be repelled. So that's what's going on. In the next step, a transition state happens, and in that transition state, uh, one of the bonds is forming and the other bond is breaking. So the CCl bond is breaking, the H's are still there, and the OH bond simultaneously is forming. And this thing will have a minus one charge. So that's my transition state. And finally, the next step, the Cl breaks away. And when the Cl breaks away, you get an alcohol that is formed. So the CH3 is now, the Cl has broken away. And instead, in its place, you have an OH, and the Cl has been knocked out. Because that's your overall reaction. This is what's happening. ठीक है, ये क्लियर है?
Yes, sir.
Yes, sir.
अच्छा, so that's what's happening. That's SN2. ठीक है, and the thing is that this is a one-step reaction. It's a one-step reaction. I mean, this whole thing happens in one go, and that's your transition state. ठीक है, that's my transition state. ठीक है, so remember this. This is going to come again. ठीक है, in A levels as well. क्योंकि the whole question comes. I mean, like everything is going to be discussed together in the question. I'd say it's a one-step reaction. What else is about this reaction? I'm just going to add the conditions over here. For this, you need NaOH aqueous, and you need reflux as well. As the next one, you've got tertiary halogenoalkanes. They undergo. अच्छा, why is this? बल्कि वो सारा बाद में discuss करते हैं. The next one is tertiary halogenoalkanes. Now, when it's tertiary halogenoalkanes, so that reaction is SN1. So that one is SN1. So what happens in tertiary halogenoalkanes? So when you have a tertiary halogenoalkanes, you get a proper two-step reaction. You got a Cl. There are other alkyl groups attached to it, making it a tertiary halogenoalkane. Now, in this case, what the first step is that the Cl breaks away on its own. The Cl breaks, and you get a carbocation intermediate that is formed. So it's a proper two-step reaction, and you get this carbocation intermediate, and it has a positive charge. The Cl has broken away. And now in this next step, the OH minus 1 comes in. So the OH minus 1 brings its electrons and comes and joins with the carbocation, and you end up with the same substitution product, which is basically an alcohol. You got another CH3, another CH3, and now you have NOH, and the Cl minus 1 has broken off. ठीक है, so is this part clear?
Yes, sir.
Yes, sir.
ठीक है, and this is your two-step. It's a two-step reaction. So it has a slow step and it has a fast step. The previous one, and this is a proper carbocation intermediate that is formed in the middle of the reaction. You could stop the reaction over here. So first thing, what's the one and what's the two? So remember, if you remember rate of reactions, in rate of reactions we studied that the speed of a reaction depends only on the slow step. So your slow step involves only one of the reactants. So the rate of the reaction is not going to be dependent on the OH ion concentration. Because if I increase remember there are two reactants, right? There's a halogenoalkane and then there is OH ions, right? So the rate of the reaction should technically depend on both reactants. It should be dependent on the three methyl groups. There's a carbon and a Cl. The halogenoalkane concentration, and it should depend on the OH ion concentration, but it does not. The OH ion has order 0 and the halogenoalkane has order 1. Why? Because if you speed up the fast step, the overall speed does not change a lot. For example, if this is 100 seconds, this is a slow step, and this is 1 second, that's your fast step. No matter how much OH ions you add into the mixture and no matter how fast the fast step becomes, the overall speed is not really, I mean, if it becomes 0.1 second, the overall speed, there would barely be any difference, okay? So is this clear that the rate does not depend on OH ion concentration? ये बात clear है? Zain, is this clear? Zohair?
Yes, sir.
Yes, sir.
Acha, so I'm just going to explain that, okay? So OH is in fast step, and therefore it does not affect rate. So what happens is that the overall order of the reaction is 1. So the overall order is the overall order is 1, which is why you call it SN1. ठीक है? Or in other ways you can say that the 1 stands for that the rate of the reaction depends on only one of the reactants. And the previous one, there's only one step and both reactants are involved, right? So the rate in this case depends on both reactants. It's dependent on CH3CH2 Cl, and it's also dependent on OH ions as well. So the overall order in this case is 2, which is why you call this one SN2. Okay. The next question that they can ask you about this is that, remember this is all AS division. So the next question that they can ask you about this is that what um क्या होता so the next question that they can ask is what will why is there a carbocation getting formed in this in the tertiary halogen alkane, and why not a carbocation forming in the primary halogen alkane? Well, what could be the reason for that? Why do primary halogen alkanes not undergo this mechanism? Why can't they form a carbocation? कोई idea किसी को why?
सर
Our
चार्ज डेंसिटी ज्यादा होती है टर्शरी में।
हाँ ठीक है नहीं tertiary so the thing is tertiary carbocations are very stable. ठीक है so the reason is that it's pretty easy to form tertiary carbocations. ठीक है tertiary carbocations or 3-degree carbocations with 3 alkyl chains have low charge density and are very stable. So they're easier to form. So as an example, if I have I mean like the previous example, if we have a tertiary carbocation, it's got more electron donating alkyl chains, right? So they are more electron. Yeah, in detail, manner we did do this in the whole Markovnikov rule thing when we were discussing alkenes. So the charge density is lower, which is why when the Cl breaks away, it doesn't really attract the Cl that much. So the Cl could easily leave. It's not going to be attracted to the carbocation that much. So the CCl bond would be very weak. So so in this particular case, the CCl bond is going to be very weak. There would be very little attraction between them. Is that clear?
यस
So in the case of
Yes,
tertiary,
sir.
the forming the carbocation becomes very, very easy. But forming primary carbocation is going to be very difficult. ठीक है 1-degree carbocations, primary 1-degree carbocations have very high charge density. And they're very unstable. Basically, they don't want to be formed. So if I have a primary carbocation, because then there's not a lot of electron donating alkyl chains, the positive charge is like really, really strong. So it would be pretty hard to break the Cl. I mean, the Cl would actually get attracted back again. So it would be pretty hard. The CCl bond would be very strong, right? Is that clear?
Yes, sir.
So in this case, the CCl bond is strong. So so it won't break on its own, and it would be very hard to form the carbocation. So in primary, what happens is because the CCl bond was so strong that it has to bond first, and that negative charge then pushes the Cl away. Somebody has to come in and then repel the Cl away. Otherwise, the CCl bond would be very hard to break on its own. ठीक है, so is that explanation clear? Sargo clear, right?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
ठीक है. अच्छा, so we're going to move to the last one, which is acyl chloride. Okay, we're done with mild hydrolysis of halogen alkanes. Now we're going to talk about the vigorous hydrolysis of, and there's going to be a new mechanism that we're going to study in this one. So this one is why do we have a vigorous hydrolysis of acyl chlorides? So I'm just going to do, okay, let me, so I've got ethanol chloride and it reacts with water and with cold water. Nothing is required. The reaction would still be very vigorous. And you'll start seeing fumes of. So the Cl is going to get knocked out and will be replaced by OH. And the H will go and combine with Cl and HCl will be formed and you'll see white fumes. And it's going to be a very, very vigorous reaction. Okay, so you'll see a lot of fumes. That's a very good way of making HCl gas. So the first question is, why is the reaction so vigorous? Okay, that's the first part. So so the reason explanation for that is that this is a very polar compound. I mean, the serial bond OCl, it's got a very strong positive charge, and which is why the water nucleophile, you don't even need OH ions. So the water with its lone pairs, there's going to be very strong attraction between the two. So carbon in in this thing, RCOCl, has a very high partial positive charge density. Why? As it is bonded to two electronegative elements. It's not only bonded to oxygen, but at the same time, it's also bonded to Cl. So as it is bonded to not one, but two electronegative atoms. So there's oxygen and Cl. So hence, there's going to be very strong attraction for nucleophiles. Okay, is this clear?
Yes, sir.
Yes, sir.
So now the mechanism, TK. Now this mechanism is a new mechanism that you have to remember. This is known as the addition elimination, nucleophilic addition elimination. So it's the nucleophilic addition elimination mechanism. So what happens in this? You've got TK starting with the first step. The first step is you've got a acyl chloride, TK with its Cl. This is slight negative, and the carbon is slight positive, and we've got a water molecule coming in. The water molecule is highly polar. This has positive, positive. Lone pairs. Now the first step is that the lone pairs are going to get attracted to the carbon that's positive. Now as this lone pair gets attracted to this carbon that's positive, the electrons in the double bond, because the double bond has a lot of electrons, so the pi electron cloud in the double bond will be repelled. Okay, that's the first step. And so this is what's going to be formed. You'll have CH3C. That double bond O will turn into a single bond, and there would be electrons accumulating at the top. There's a Cl that's already here, which is right now at this point not doing a lot. So there's a Cl over here, which is at this moment not doing much. And the water over here is going to be, it's going to bond. And the water over here gets a positive charge. Why? Because the water lone pair is now, it donates that lone pair to carbon and bonds with the carbon, and the carbon pushes those electrons which were in the double bond upwards. So that side gets a negative charge. So is the first part clear? This one?
Yes, sir.
Yes, sir.
And so then what happens? The next thing that happens is that the lone pairs on the top near oxygen. So you've got bonded electrons over here. The double bond reforms. Okay, because the carbon-oxygen bond was very strong, so it was not able to break it completely. The reason the electrons went towards oxygen was that oxygen is the more electronegative element. So oxygen is naturally going to attract the electrons, and but since it was a double bond, so the double bond did not break, and eventually after some time the double bond is going to reform. The electrons are going to come back, but as the electrons come back, the electrons over here are going to be repelled, and your Cl gets knocked out. So now your Cl has been knocked out, and what you now have is CH3. See, the double bond with oxygen is back, and you've got this. One second. And then you've got a positive charge over here, and the Cl has been knocked out, right? Is that clear? You clear that the oxygen
Yes,
forms the double bond back, and your Cl, and as those electrons come back, the Cl gets knocked out. Now the last part is that the oxygen that initially in the first step lost electrons to the carbon, right? I mean, it had a lone pair, but that lone pair went and bonded with carbon. That oxygen had a double bond. It wants its lone pairs back. So what happens to this H over here is that so what happens to this H over here is that the Cl comes back and donates its electrons to H. what does the H do? The H had electrons over here. The H is going to give its electrons to, it's going to give its electrons to oxygen. So the final thing is that you'll get your final product now, which is you'll get CH3, C double bond O, and at the bottom you have an OH now. The oxygen has both its lone pairs back, so it's neutral now. And the Cl gets the H, so it's now HCl. Okay, that's the entire mechanism. Okay, so it's kind of a bit longer mechanism compared to the ones that you've already studied. I mean, electrophilic substitution was kind of a lot simpler. This one is slightly more detailed. Okay, so that's it. That's nucleophilic addition elimination mechanism, right? Clearly, this one.
Yes, sir.
Ji, sir.
Yes, sir.
I said, plus you won't see a lot of remember you have to note this down because you won't see a lot of questions in past papers on this because this was recently added. I think probably in 2022. So this one there won't be a lot of questions while you're practicing past papers. But now it's very important because you have to keep this in mind that if you don't see this in past papers, you have to remember this because that's going to come in your exam, okay? I said, so that's it. So that's hydrolysis. So we're going to do some questions related to hydrolysis. Let me just I said we did electrophilic substitution questions. Now hydrolysis. 1 second. Yeah. I said so here's an acyl chloride, right? And see, it's just a 1 mark question, but the whole thing is discussing the mechanism, right? He says nylon 6 monomer is hydrolyzed. Now you can clearly see that I mean that part over there, that's an acyl chloride, right? And it's getting hydrolyzed. So he's saying what? By considering the 2 steps in the mechanism of the reaction, complete a table placing 1 tick in each row to indicate the type of bonds broken and formed during the entire mechanism. So bonds broken, sigma bonds, or pi bonds, bonds formed. So let's go back and have a look at the mechanism, right? What's going to happen? So first step, what bond is broken over here in the first step?
Pi
Pi,
bond.
pi bond, okay? Pi bond breaks, right? And what bond is formed in the first step?
Sigma bond.
Okay, this single bond is formed, right? As a next step, what bond is first step? I mean, remember, this is not really considered a step. It's just that the H then breaks away. Mainly, it's these 2 steps. Uh, what bond is formed over here? That's a pi bond, right?
Pi bond.
And what bond is broken over here? That's a sigma bond, right? So is this clear that in both steps, like in the first step, uh, now he's talking about the overall reaction, right? So both pi bonds are broken and pi bond is formed back again. Sigma bond is formed, and over here sigma bond is broken as well. So in both steps, both things are happening, right? Is that clear?
Yes, sir.
Yes, sir.
Okay, so pi bond is formed, pi bond is broken as well. Sigma bond is formed, sigma bond is broken as well. Okay, next one. So he's talking about the comparison of hydrolysis. State and explain the relative rates of hydrolysis of the following compounds. So which one is which? Which one is the halogenoalkane? Like this is exactly what we did. I mean, the first one is the halogenoalkane. That would be the middle one. This is a chlorobenzene. This is going to have no hydrolysis, right? Is that clear? You cleared it? No hydrolysis for this one.
Yes.
And this one is going to have, this is the acyl chloride, cetyl bond OCl. This is going to be it's going to be a very vigorous reaction, right? Okay, so it's going to have a very, very vigorous reaction. अच्छा अब ये कि 1 second, let me. So what is needed now is you need to explain this. Explain the relative rates of hydrolysis of the following compounds. So what you're going to write is that you just have to explain why this has no reaction. What you'll write is you'll just write this stuff, okay, chlorobenzene. I mean this part. You're just going to write that the lone pair on Cl overlaps with the benzene pi electron cloud, and the CCl bond strength and charge density increases, which repels nucleophiles. That's it. Okay, that's 1 mark. I mean that's one part of the question. And then you're going to mention why this has a vigorous reaction. So the reason acyl chlorides have a vigorous reaction is it's this part that this carbon in RCOCl has a very strong partial positive charge density as it is bonded to 2 electronegative atoms. Hence, there is strong attraction for nucleophiles. That's it. You don't have to explain this one. That's the middle part. Okay, it's a 3 mark question. One for explaining why this one is the fastest one for explaining why this one is the slowest or no reaction. And the other, there's going to be 1 mark for the order of the 3 things. Okay. So remember, whenever there's comparison questions, you just go for the 2 extreme ends. You just explain those. Okay. Is this clear?
Yes, sir.
So again, it's exactly the same question. I mean, remember, you're going to get a lot of times you're going to get exactly the same questions. Acyl chlorides, alkyl chlorides. Alkyl chlorides are halogenoalkanes. And remember, aryl chlorides are chloropenzene. I'm going to add this over here as well. That, copy, start, man. I mean, the other name for this is aryl chloride. Aryl just means benzene. And this one, halogenoalkanes, is also referred to as alkyl chloride. That's the next one. Chlorobenzene and chloroethane have different reactivities in nucleophilic substitution reactions. So identify a suitable reagent to illustrate the difference in reactivity. The reagent chosen should give visibly different results with chlorobenzene and chloroethane. Now, so I'm going to add one thing because they all have Cl. So how do you get a visible result? Like if I want to show the difference in reactivity. So one way to get a visible result in reactivity difference is adding silver nitrate. Because as soon as the Cl gets displaced, a white precipitate is going to be produced with Cl ions. Okay, so make sure you remember this as well that to get visible results, because every time a Cl ion gets produced, right? Add aqueous silver nitrate. So the Cl ion displaced will form a white precipitate. So as soon as the Cl ion gets displaced and the reaction happens, you'll get AgCl solid. ठीक है, ये बात भी clear है? That's how, if somebody wants to see a visible result, that's how you're going to do that. ठीक है, is this clear?
Yes, sir.
So chlorobenzene is not going to react. Chloroethane is definitely going to react. Okay, so you add silver nitrate and you add NaOH aqueous and you heat. This one would give a visible result. Describe equation, describe any reactions that occur. So in chloroethane, you are going to get a reaction. So you can write the equation for that. So बस last में मैं लिख देता हूँ कि it's like if you add OH ions, hydrolysis will happen. and an alcohol will be produced, and the Cl ion is going to get knocked out, and the Cl ion will then, because you've added silver nitrate, it's going to go to silver ions and it will form AgCl. So ठीक है, we'll do some more questions, go through some more questions फिर next class में करते हैं, ठीक है?
Okay, sir. Allah Hafiz.
चलिए, okay everyone.
Thank you, sir.
Take care, Allah Hafiz.